Hi students, now we are going to discuss the law of radioactive decay which was explained by Soddy and Rutherford. Soddy is the research student of Professor Rutherford. Now we know that during radioactivity, if you take a sample of a radioactive substance having initial number of atoms, after each second or after each year or so many lapse of time, the number of atoms will be continuously decreasing. So the mass as well as the number of the parent nucleus will be continuously decreasing. This is only called as radioactive decay or radioactive disintegration. Now I will take for example N0. This denotes the initial number of atoms. So this is the initial number of atoms at time t equal to 0. Then capital N represents the number of atoms remaining, okay, after t, after a time t. Then how many number of atoms is lost? No, that is n0 minus n. If you divide this by t minus 0, then this is denoted as dn by dt. So how many number of atoms have decayed in a time t? That is represented by dn by dt. This is only called as rate of disintegration or rate of decay. So this only is called as rate of disintegration or rate of decay. Okay. Now what is the statement of this law of radioactive decay? The number of radioactive atoms disintegrating per unit time, or the rate of disintegration of a radioactive nucleus, is directly proportional to the number of atoms of the original kind which is remaining after a time t, that is at that given time t. So this statement is mathematically written as dn by dt is proportional to capital N. So what is capital N? We have written already. This is number of atoms remaining undecayed after a time t. So this is the mathematical statement of the law of radioactive disintegration. Okay. Now this is proportional to n. So it must be equal to some constant into n. Therefore I will write this dn by dt is equal to a constant lambda multiplied by n, where this lambda is called disintegration constant or decay constant for a given substance. That means if you take uranium, either you take 1 gram of uranium or 1 kilogram of uranium, lambda will be the same. But the value of lambda of uranium is different from the value of lambda for thorium or actinium. So lambda is called by the name decay constant. But in this I am going to introduce on the right hand side a negative sign. So why I am introducing a negative sign is because initially if you take a fresh sample of uranium, the number of atoms emitted per second will be more. But after some time, if you see, very less number of atoms only will be emitted per unit time. That means the rate of disintegration is continuously decreasing with time. Also, the number of atoms of the original kind, the number of parent atoms will also be continuously decreasing. That is why we are introducing a negative sign on either the left side or the right side. So dn by dt is equal to minus of lambda into n. Okay, I am rearranging this equation once again like this, or this dn divided by n is equal to minus lambda into dt. I have rearranged this. Okay, at the beginning the time was taken as 0. At the beginning the number of atoms of the parent or the original kind was n0. After a time t, how many number of parent atoms are remaining is n. So I am going to integrate this equation, call it as first equation. I am going to integrate the first equation between the limits. So integral of dn by n, integral of dn by n is equal to minus lambda into integral of dt. Now, what are the limits of this number of atoms? Initial number of atoms was n0, and after a time t, the number of atoms remaining undecayed is n. So, the lower limit is n0 and the upper limit is n. Similarly, here at the start of the process, the time is 0 and the time later is t. So, it is 1 by n into dn. Integral of 1 by n dn is log of n. So, this is a logarithm of n to the base e. Exponential. E is the exponential constant. This is also called as ln, ln, ln. So, better if you write log n to the base e, and it is between the limits, okay, between the limits n0 and n. And this is equal to minus of lambda into integral of dt is t between the limits 0 and t. Now substituting the lower limit and the upper limit, the left hand side will become log n to the base e minus of log n0 to the base e. This is equal to minus lambda into t. The lower limit will vanish. Therefore, right hand side is minus lambda t. Now, by formula log a minus log b is also equal to log of a by b. So, this can also be written as log of n by n naught to the base e. So, this is called as natural logarithm. Natural logarithm can also be written as ln, ln. But this is better if you write a log to the base e. So the right side is now equal to minus lambda into t. Okay. After this I am going to take exponential of this equation. So I can write this r n by n0 is equal to e to the power of minus lambda t. Okay. R n is equal to n0 into e to the power of minus lambda into t. So this is the final equation. This is n is equal to n0 into e power minus lambda t. Suppose if you take t is the time after which n is the number of the parent nucleus remaining undecayed. So n represents number of atoms remaining undecayed. So how will you find the number of atoms which has decayed? Decayed means 1 minus this n. Okay. Now you see that n is the number of atoms of the parent nucleus. If the number of atoms of the parent nucleus continuously decreases, what happens to the mass of the parent nucleus? Mass also will be decreasing or not? So I am going to write an additional equation in terms of mass. So if you write the same equation in terms of mass, m must be equal to m0 into e to the power of minus lambda t. This equation is directly helpful in finding the mass of the nucleus which is the remaining. So these two are nearly one and the same. This is in terms of number of atoms remaining, and this is the mass of the sample which is remaining undecayed. Okay students, now initially I told you the significance of this negative sign. Why it is negative? Because continuously the parent nucleus number is decreasing, mass is decreasing. Similarly, the rate or the speed of this radioactive process also will be decreasing. So initially the rate of disintegration, if we call it as R0, and after a time t the rate of disintegration as R. I can also write another equation, namely R is equal to R0 into e to the power of minus lambda t. So here R represents the rate of disintegration. So initial rate of disintegration is R0, which will be high speed. Then R capital R is called the rate of disintegration. So this is also called as activity of the substance. The rate of disintegration is also called as what? This is also called as the activity of the radioactive substance. So freshly, if you take a sample from the ore, uranium is taken from the ore, first the rate of disintegration or the activity of the substance will be very high. As time proceeds, the activity will come down. So, my dear students, all the three equations are very important. So, we have derived n is equal to n0 into e power minus lambda t. This equation gives the number of atoms of the parent, the original nuclei remaining undecayed. Fine. Hope you have understood.